All right, a very warm welcome everybody to the session today. This is one of the series of webinars that we do to share our learnings with the technical community. Sometimes it's on Telerik technologies, and a lot of time it's on technologies that we find cool and that we want to share with you. So today the topic that we have picked out is something that is of extremely valuable nature to people who are writing applications for companies or enterprise grade applications, or people who hope to write enterprise grade applications as well. This is called Introduction to Inversion of Control and Dependency Injection, and the technology that we are going to use is .NET to illustrate the concepts, and specifically we are also going to delve deeper into ASP.NET. So I am Abhishek Kant. My contact details are mentioned on the screen right now, abhishek.kant@telerik.com. My office detail phone in terms of the phone number is also mentioned there. You can find me on Twitter with my handle Abhishek Kant. I've worked earlier with companies like Saturn Computers and Microsoft Corporation. Co-presenting with me is, Lohit GN. He's technical evangelist with Telerik, also a Microsoft MVP and author of a book as well. His contact details are mentioned as well, and his Twitter handle is there as well. So you can find him at any of those locations. All right, so today we are going to begin the webinar in a slightly different fashion. It's going to be trying to understand what is the problem that we are trying to solve. And if you're writing enterprise applications, these are the problems that you may very well be familiar with. Well, obviously, you want to write maintainable code. So first, when I'm going to say all this, let's talk a little bit more about what does enterprise app mean. One, an enterprise app is extremely big. It may be composed of multiple projects. It may have multiple moving parts, and obviously a lot of code written in all those different various projects. So the first problem is writing maintainable code, which means if one piece of the application seems to be not functioning correctly, you should be able to get to the specific project pretty quickly in order to debug or check out how that or where that feature was implemented. If everything was implemented in just one project, then obviously you will take a lot of time to actually go ahead and even locate where the problem is. And this problem becomes more acute when you have many projects in the system there. So writing maintainable code becomes very, very important, and that's one of the problems that we are going to solve today. Of course, today I want my application to talk to SQL Server, but hey, I want it to talk to another database, let's say a service. The application is no more using a SQL database. It's going to be using a REST-based service which is coming from somewhere else. So how do you minimize the impact on the code and still provide this changeover in functionality? So that's called provision for extensibility. Next, you have different multiple repositories. I have just used data stores as placeholder because that's one of the most frequently used, but the repositories can come in for different needs. It could be for data stores, it could be for logging, it could be for security, it could be anything. The point being, today you're using a specific feature, tomorrow or a specific kind of repository, tomorrow you may want to use another repository. So how do you provision for those things? And of course, if it's going to be a large project, people are going to be working in parallel. So how do you make sure that different people are working on different parts of the code and still everything comes together? So there's got to be, pieces that are atomic in themselves so that they are not as much dependent on other pieces of the giant application that's being written, so that nobody's waiting on anybody else to complete this development. If they take a dependency on somebody else, you'll have to wait till the other person completes that job. So how do you do that? And I mean, for a simple project, maybe not as much, but for a large project, these considerations are extremely important. And of course, writing unit tests, which is making sure that you have minimum amount of dependencies on other systems or other moving parts, so that you can just test the functionality that you have developed. So hope this properly addresses some of the challenges that we have observed in various enterprise applications, and probably you would agree with many of them as well. If you have more considerations that you want to put out, please definitely feel free to put them in the chat window. All right, so with that, with knowing what we are trying to solve today, let's see what is the agenda for the day. We're going to actually take a lap around the sample application that we are going to be using today. The sample application that we have chosen is slightly different again. This time, it's not just hello world. It's going to be slightly something that you have, that you probably would be coming across almost any time. We will see, you know, what are the problems with that sample application, and we'll move to loosening that coupling. So it will be tightly coupled, and we'll see how we can loosen that so that it becomes more extensible, or more, you know, all the other things that we wanted to do with this in the beginning. And then when we have loosened that coupling, can we use another infrastructure to further make it enterprise grade? So we call that composition, and then we'll look at doing that composition. And the composition tool that we are going to use today is going to be an inject. It's not a Telerik tool. It's pretty much an open source tool. So we'll see how that goes. During the presentation, I'll pretty much be using simple console applications so that you can see what's going on. But then when Lohit comes in, he will switch into showing you ASP.NET MVC and bring out how dependency injection can be directly used in MVC. So hopefully that is an agenda that is what you were looking for. But in case you have you know, more thoughts around what you wanted to cover today, please feel free to put them in the Q&A panel. During logical breaks, we'll see if we can cover that today as well. All right, so first review some of the basic concepts. I'm pretty sure that you're all familiar with at least these things. You know what classes are in at least C# or even in Java. I mean, they're not that different. The scope of the classes, they can be public, private, protected, internal, all of those. You may be familiar with interfaces and abstract classes. Interfaces are non-concrete, or you can't basically create concrete objects of, and you can implement multiple interfaces in a class. An abstract class is similar to interface, but it can be instantiated in terms of you can have concrete implementations in there and things like those. Dependencies is something that we will understand in more detail today, but put very simply, a dependency is nothing but when to perform your function, you need to rely on something else, which means today if you were going to author a simple application that was going to retrieve data from SQL Server, for you to display data from SQL Server, you needed to have a dependency on ADO.NET if you're coming from that route, or on any of the ORMs if you're going to come from Entity Framework or NHibernate or from Telerik Data Access Worlds. So there is going to be a dependencies on them. In absence of that dependency, your core application will stop functioning. And that leads to coupling, which is a tight coupling of the dependency. Having a dependency really ultimately leads to having a tight coupling with them. So we'll just kind of go and see how we loosen that up to make it more sensible. And then once again, instead of starting with, you know, what it is that we are going to look at, let's look at the desired end of what it is that we want to achieve. What we want to achieve today in all of this is to lose or is to achieve loose coupling on the application that we are going to see. So that's the end objective, and let's keep that objective in mind. And in addition to the loose coupling, we also want high cohesion in the individual projects that we are going to have, which means the simple or the single class should be responsible for doing a single thing. So it's going to be having high cohesion, but then it's going to be loosely coupled with other surrounding dependencies. So we'll see how we can achieve all of them. The diagram there on the right-hand side actually shows you how we are going to break down this presentation, because there's going to be a lot of jargon being thrown out today, and I think you're already jargon heavy by now. But essentially, the way it is a loose coupling is a concept, and one of the ways of implementing loose coupling is called inversion of control. There are more ways of doing loose couplings, but today we are going to look at inversion of control itself. Now, within inversion of control, there are a few strategies that you can take. The one that we are going to take is called dependency injection. So in most of the terms today, inversion of control and dependency injection will be used interchangeably, but please do remember that on a theoretical level, there are more ways of achieving inversion of control than just dependency injection. Now, dependency injection itself can be of multiple types. To keep it simple, the one that we are going to look at today is constructor injection. And to achieve, the injections, we are going to use DI frameworks, and there are many of them that are mentioned there. But the one that we are going to use is called N-inject. You actually don't have to use a DI framework if you have to achieve loose coupling, but it's available. It eases your task, so you might as well use the frameworks. So till about constructor injection is all that we will do, even without needing a DI framework or a dependency injection framework. So it's all going to be demoed to you today, and to make it more I would say concrete, let's look at what we are going to develop today, okay, and what we are going to be working with today. So I'm just going to bring in a quick view of what we have, so that it will make more sense once the application is in front of you. Give me a second, and I am going to run this application and bring the screen in front of you. So it's running. It should just come up. So I mentioned that I'm not going to touch web application today, and this is purely the end result of all the work that we have done. And I want to start here because I want to show you what is it that we are building. All right, so let's take a look at what we are building. It is essentially a simple survey application. It gives you an option of selecting which survey you want to take. Then it will display the list of questions. You can then select whatever options you want to, and then say submit, and then it will go and store it in the database. Next, it will also take the results out and show it to you graphically. So while all this is possible today, let's see how this functions. I can simply say select survey. I can choose one of the surveys that's available, and by simply choosing this survey, it will go to another page. And as you can see, the query string has the survey ID, and in here you can see different questions that are available in that survey. I can choose, my rating, and then I can leave a comment. This is good, and then I can say submit. So what has happened here is this has gone back to the database. All right, so this is how the application is going to function, but this was only to give you an idea of what is it that we are trying to build. Now, let us actually go into seeing the concrete work that is being done. Now, the way that you probably are thinking of architecting this is in a three-tier manner. Now, the three-tier manner, which you will already be familiar with, has SQL as the data layer, and then you have ADO.NET or ORM as the data access layer, the more or the next simplest step is to have the UI interface, which would be a console application, a Windows form or a web form or an MVC interface or whatever kind of interface you want. The more enterprising amongst you would say, oh, I need an intermediary business logic layer as well. Sure, that's also possible. But this is pretty much how most of you would be looking at. So, well, what you have there is actually a 3-tier architecture. Let's take a look at what we have. So in here you will see the database which I have created. It has a lot of tables, but to simply show what are the tables and the relationships between them, this table should explain it. Surveys table is the one that we are actually going to be working with today, but know that it has all of these other associated tables and relationships existing as well. So surveys is the one that has the title that we are going to work with today and show the list of surveys that we have, and then probably try and display the title. All right, so I have run this, I have added a single row in this table, which is the surveys table. And you can see the single row that I have is called CouchDB course participant satisfaction. So this is the SQL part of the application. Let's switch back to what we were talking in terms of having a 3-tier application. So SQL Server is pretty clear, I believe. The next obviously is the ORM and the UI interface as well. All right, so before I get into this, which is symptoms of showing you the tight coupling, I want to quickly get into showing you how this application can be seen and built in exactly the same fashion which I have built now. To speed up things, what I have is a simple application created. In here, I have just done the ORM piece, which means I have this entities model that I've created, and well, you could use any ORM framework that you have. I am currently using simply the entities, the Telerik data access framework. It exactly reflects the same thing. So I'm first going to, let's say, build it. And to consume this, I will actually add another project that I have built up, and it's a simple command line project. This is just to save you time and show you what's going on. So you know that this is the ORM layer, and the ORM layer is now going to be utilized in the application that we have written. So if you notice, this command line or a console application has references to a few things. This has reference to the survey SQL data, which is this project here, and then it has references to other ORM libraries. So Telerik Open Access is what I'm using, or Data Access, and that's what we have. Now let's go and see how the command or the console application looks like. So very, very simple. It is just this. What I have just done here is I have created a new instance of the ORM object in Telerik Data Access. It's available as surveys model. So I've just newed up the surveys model. And I've written a simple query, which is a link query, to retrieve all the surveys that are active. So if you notice in the surveys table, my active ID is set to 1. So this is an active survey at this time. Now, all I'm then going to do, for simplicity's sake, is going to display the title of each of the surveys, and then it's going to be console read line. All right, hopefully this should function. Let's try and run it and see the output that it gives. All right, so you see the data that we were going to retrieve is right here, which is CouchDB course participation satisfaction. All right, so you've seen how to run it, and well, this is absolutely functional. Nothing that is kind of stuck up there. But let's see what are the problems that we face in such a situation. So the first problem, as you can see, is we have a direct reference to a concrete class. Notice, coming back, I have a new concrete class. So this surveys model is a concrete class that I am using. And remember, the objective is to get to loose coupling. This is a beautiful architecture. It's a 3-tier architecture that we are using. But now we are going to decouple the components that are otherwise meshed into each other. Now, if I had to do anything, if I had to run this command line, of course, you would need to have a concrete surveys model. Otherwise, this command will give you an error right away. There will be a compile time error there itself. Now, here you see there is a direct reference to a concrete class, symptom of a tight coupling. I'm creating a new object explicitly. Definitely tight coupling. One class depends on another, it does. So my program class, which is the main execution entry point here with the main, depends directly on surveys model class, again tight coupling, and of course this is only limited to a single implementation. So if I'm doing some sort of a DB work, which I am, I really can't do anything here till actually going and hitting the database. Well, question that is in your mind probably now is, oh, but why do I need to change anything? This is 3-tier. That's something that works beautifully. Why should I change anything? Well, the reason is coming back to the same slide which was I showed you in the beginning. This is the reason why we are doing everything. Now, if you're going to be doing anything else at this time, you don't have provision for extensibility. It's pretty much stuck with SQL Server at this time. Changing it to a service means you're going to have to come in and change the code significantly. You can't provision for changing data stores that quickly. You can't do parallel development because you have a dependency on the guy writing the ORM layer. And then, of course, if you're going to be testing the or going to be using the unit tests, it's going to be difficult because if you want to do anything with this core entry point, you have to new up the concrete class as well. So from here, which is very, very tight coupling, how do you move to decoupling this as well? Now, the simple way of doing it is presented here in 4 steps, and it's pretty simple as this, which is you extract the interface, and I'm assuming you already have an interface working. So you're going to extract the interface from the concrete implementation. That's step number 1. So now you have a different interface which has the same implementation details from the concrete class. Now you're then going to use the class to use this interface, which means your concrete class that you had a dependency on need to implement this interface and hence create its availability where it's going to be used. Next, we are going to make object instantiation somebody else's problem. So I'm not going to own up to saying that I'm going to manage the lifetime of the object. So this is simply going to be making it somebody else's problem. And then finally, hopefully, if I need to, I will use dependency injection. So let's see what happens when we are going to do this, which is move from the 3-tier that we have, which was working beautifully, by the way, to making it even better, to making the code basically an art form. We're going to follow these 4 steps, and then we are going to achieve the loose coupling that we talked about, and you will see how simple it then becomes to achieve the objectives that we set out to achieve. All right, so slightly changing the architecture of the application using the 4 steps. After you've done those, or even after you've done the first or second step, you will notice the architecture changes a little. Instead of now talking about SQL database, ORM layer in the middle, and the UI layer, all I'm really talking about is, oh, there is a domain model in the center of this whole application architecture. This is what we are calling the core, the domain model. This domain model also does not have dependency on any other thing. If you notice, we are starting from an object or a domain model that actually takes dependency on nothing. It is a self-contained object by itself. Next, we have domain and application services. So to achieve or talk to the objects in the domain model, you will need to have some domain and some application services available there as well. So in our case, this is going to be implemented as repositories. So we'll see what those repositories are. Repositories will enable access or will allow communication from the domain model back out to infrastructure services which are located outside. Now, another feature of repository is that it will take dependency only on the domain model. And as we go out, we are going to increase our dependencies on the objects within it. So the outer layer that is currently there is actually the one which is the most pluggable. So you can remove one UI element from there and plug in another UI element there very quickly, which means I have today a command line. Tomorrow I can use a web forms or an MVC. I can author tests very quickly. And in terms of infrastructure, I can use a SQL database. I can use a NoSQL database. I can use a service, or I can simply mock things up. So that is the change in the architecture that we are going to observe. All right. So let me just close down everything here first and take a look at the Solution Explorer. As you can see, the architecture now is composed of a few more projects. When we had started just with SQL data and show SQL data. We had talked about extracting the interface, creating the core objects. So that's what we have done here. So let's review the work that is done. All right, so zoom out, sorry. If you look at the core object, Survey Core, which is the project that I'm using, I'm just going to change the architecture here a little bit. So what you will notice is it has dependency on nothing, really, nothing of the project here or any specific pieces from the libraries that I'm going to use. This is a standalone survey .core or the domain objects. So this is simply the survey.cs, and it is reflecting exactly the relationship or the application or the data structure that was there in the database. So the relationship is reflected by having aggregation here, and this is a list of survey questions, which is a part of the survey class itself. So this is one of the core objects. So the attribute that we are going to be using today is the title, and that's what we are going to be using over and over again. Similarly, we have objects, business objects for each of these types, which is survey questions, survey responses, and response results. So if you notice, it is not a one-to-one mapping to all the data tables, because that was in the third normal form. Here we are going to work with these individual objects that we have identified that make sense for the application. Now, the next thing I had mentioned was to extract and create an interface based on the implementations that we want. So if the core was the data that we are going to operate on, the operations that we are going to perform should be captured in the survey repository, which is basically the repository that we are going to have. It's a pretty small repository, and if you check out the references, really the only reference it has is on survey.core. So everything, since this is an application service which is coming from outside, this is going to be something that's going to take a dependency on Survey Core itself. Now, why I am talking about dependencies again and again is we do not want everything to depend on everything. We want very specific dependencies explicitly stated so that we can get to making that more intentional, and thereby making the changes much more easier to do. So in the repository, if you notice, I have simply added the functions that we want to do. For example, get all surveys is the one that we are going to use right now. There are, so you are familiar with the CRUD interface. This is sort of part of that CRUD interface. Can you actually new up this repository? I said this is an interface, so actually you cannot. This is just a contract that you've just established. Any concrete implementation has to implement this contract, and this implementation is done in a concrete implementation called survey repository. Now, this repository currently has dependencies of the following nature. Number one, it has a dependency on the survey core, obviously that was required. And then we have dependency on survey.i repository, which was where the interface definition exists. And this has concrete classes written for SQL data, so connecting to a SQL database, and something which is mind-boggling is just mocking it. So we are going to mock out everything that is there. All right, so let's first go into a situation where, let's say, even SQL database was not available to us. So how would your repository look like in that case? So what I have done here is created a simple mock implementation. I have just done mock survey repository inheriting from iSurvey repository, and you can see the using statement come here. All I'm doing is I'm going to only implement or mock one class. If you notice, I will not use anything from SQL. All I'm going to do is say that, hey, I'm going to create some mock objects, and right here I have two surveys that I am mocking. By the way, if you're not familiar with mocking as deeply, this is basically I'm using Telerik just mock, mocking it is extremely simple using just mock. For example, all I'm really doing here is I'm going to say di MVC container, and so this is nothing but I'm creating some objects which are going to be dummy objects, and any time that repository is going to ask for any of the methods or for the objects from there, the mock object, instead of going and actually reaching out to the concrete or going and reaching out to a SQL repository, is just going to return from here with this little data that we have put in here. It's very simple to do. So all you're going to do is, let's say iSurvey repository, mock repository. Telerik gives you integration from just code itself. So you can say create a mock on mock repository. So your first mock is created right here. And then what you can also do is say implement this mock repository. So you can say then arrange a mock, and it's now asking you what all members to mock. So it has gone and seen what all members are available. So I'm going to say just one. If you notice, currently it has given me this object, which is a default, essentially an empty object. But what I really want to do is not return this empty object, but because we have created our object earlier called mock surveys, that's what we want to return. So notice this is exactly the same code that we have written earlier as well. And finally, this expects us to return a list of surveys. So I can simply say return mock repository dot get all surveys. So if you notice, get all surveys is the function or the operation that we had added in the repository, and this is the only one we are currently mocking. The rest of the interface elements are all just not implemented. All right, so we have a concrete implementation in the mock interface as well. Now what do we do? So if you go back into our application, which is show SQL data in the application here, you notice that we had a concrete implementation here. So we want to change this out. We don't even want to use SQL at this time, because by removing this, we can actually get to SQL very, very fast. Let's see what we can do. So the first thing probably I want to do is to well, add some references. So currently this only has references to SQL survey.sql data. Oh, actually I don't want to use this, because now I am not going to take any dependency on SQL data. And because I am not going to use that, I probably even don't need the ORM layers in here. So I can even remove those from here as well. So what am I going to take dependencies on? I'm going to take dependencies on survey.core, survey.repository, and probably survey repository. So in the solution, let's see. So we have survey core, we have survey repository, and go to survey iRepository. All right. So we have we've added all of these here. So if you notice, all the references should be available here. Yes, they are. And now we're going to modify this code a little bit. So survey.data. So instead of using the survey data, I'm going to say survey core. I'm going to say survey repository. I'm going to use a concrete implementation here and say using survey.iRepository as well. All right. So what do we want to do now? We don't want this. So what we want to do is say iSurvey repository. Now this is the class or this is the interface type that I want to use. Now the advantage of working with repositories is that I can change whatever I want, however I want. So at this time, if I said iSurvey repository equal to, let's say, new mock survey repository, I have improved this immensely already, which is I have moved from a concrete implementation to being able to replace this at any time because of the iSurvey repository right here. All right, so in the mock survey repository, in there I don't even have to write these link queries, because all of them have been captured in the operations that I had written in the interface implementation, which is the mock survey repository. All I have really to do is to call this get all surveys function. So all I really need to do is to say something of the nature of remove this. I can simply say, well, repo dot, and you can see the IntelliSense come up. So get all surveys. Well, obviously I don't need all of this to come through. This was all specific code that is already made a part of the implementation, which is, so now if you look, your code looks much neater and much better. The implementation details have been left to mock survey repository class, and now once we use this, you can see how simply we can move to the SQL survey repository as well. So this is just one way of doing it. I mean, if you were doing it in a real scenario, I would probably even segregate the survey repositories out, these concrete implementations out as well. All right, I am looking at the watch and it's almost about 4. I know Lohit has also to run through his schedule. So what I'm going to do is I'm just going to run this at this time. And let's see what we do further. I know we already are running out. So what I'm going to do is I'm going to say show SQL repository and run this application. So what you expect as output is just these 3 items. Let's see. It should say, is it not running? Oh, it is building. Okay. Well, those are the 3 that we had added. And notice how even without the presence of a SQL database, you're able to implement the same functionality and then just mock it up. This is a great improvement over how you could work with the concrete classes. Now, if I go from here and look at the SQL repository, you will see the same classes being implemented, and all the implementation details, which is the query, which is this, returning of what do we want to return, all of this is encapsulated within get all surveys. I have used some other helper libraries here just to make it better, like the AutoMapper, but let me just go and show you how simple it is when I want to change a repository from mock to a SQL repository. All right, and just by switching a single line of code, you get SQL there. Isn't this magic? This is what we were talking about. You've switched out a mock with a actual implementation of the SQL library, DI course participation satisfaction. So you see this data come from database, while earlier it was just coming from mock. So mocking is an equally important concept in the DI world. So you've already achieved actually quite a bit of the work that we wanted to achieve, which is you have already done extraction of the interface, you've already done modification of class to use the instantiation. Let me actually pass it on to Lohit because he will have the exact example going forth for the ASP.NET MVC application.
As rightly pointed out, we still haven't seen a DI in action, but what has set as the context is the concept of inversion of control, meaning let's give somebody else the headache of creating the object, but I will just let somebody know that, hey, I need this object, so that's what I will do. So that's inversion of control, meaning traditionally you are used to programming in such a way that if I am a class A and then I needed class B, I would readily go ahead and then say class B is equal to new class B and then instantiate and then start using it. But with the concept of inversion of control, what you're doing is you are inversing that control, or you are inversing that that particular task of creating the object. You will just tell somebody that, hey, I need the object, and then that somebody will go and then create the object for you. So this is something that I really found the IoC being simplified. So I'm pretty sure many of you are aware of the sport golf. So basically there's a hole and then you need to putt a hole from a particular distance, and then you use different they call it as irons or they call it as clubs. So there are different clubs to putt from different distances. So when you basically you as a person who's trying to putt the ball, what you will do is you have a caddy with you. So basically that's the guy who has a question mark in the picture. So what you will say to the caddy is, hey caddy, I need the club. So you'll just, I need a putter club, or I need an iron club, or I need a wedge club. That's all you will say to him. It's the caddy's responsibility to actually go look into the bag and then figure out, okay, which one is an iron club, which one is a wood club, what is a putter club, and then just give that particular club to you. So you being the client object, you just say, hey, I need class B. So the dependency resolver is nothing but the container, or the inversion of control container, or it's normally also told as DI containers or IoC containers. So basically this is as simple as it can get in order to explain what is DI or what is IoC. I'm a client object, or I'm an object which I need another dependent object. So I will just tell the container that, hey, just give me this particular object. So that container is responsible to go ahead, figure out what is the other dependency that the guy has, and then make sure it builds up the object, and then just, hey, here you go, here is your object. So now I have given away my headache to somebody else, or I'm not going to be hard wiring things, or I'm not going to be doing hard referencing of objects. Rather, I will say, hey, I need this object. So this is as simple as it can get. it's not mine, by the way. This is actually a picture that I found on my favorite site, www.asp.net. I was just going through and then figuring out, what do the Microsoft guys talk about DI and IoC, and then this is something apt that I figured out. If you see here, client object, it says give me an iClub, and then the dependency resolver is like, okay, I have a container, and then I have different implementation of iClub. That's wood club, iron club, wedge club, putter club. So it knows that I need a putter club now, and then it's going to give me back the putter club. So that's IoC DI simplified. Now coming back to ASP.NET MVC, I know we are at the 1 hour mark, but I will take another 15 minutes or so to just finish up this, some interesting stuff that's coming up. So basically, in a nutshell, the basic MVC pipeline is something like this. You get a request to a particular route. So within the MVC pipeline, basically within the pipeline, there is something called as a route handler. What it does is it knows that there is a pattern. It matches the route that came in with a pattern, and then it kinds of figures out what is the controller that's been asked and what is the view that should be provided in all those things. So the route handler goes ahead and then creates the controller. The controller will either give you back a view or give you back a data or whatever it is, and it sometimes will use a model. If we go one level deep, have you ever kind of wondered as to the controller is actually a plain old C# class. We call it a SPOCO, right? So it's a plain old C# class file or a class an object. So who instantiates that object, right? I just said, /home/index, but somebody should have instantiated because it's a class, and then class has an index method, and then index method gives me back something. So that something is done within the pipeline. This is something that happens within the MVC pipeline. So the MVC handler, what it does is it by default has certain defaults available. One of the defaults is known as default controller factory. So basically the controller factory is responsible for creating the controllers and then instantiating them and saying like, hey, go do this particular action or execute this particular action. So out of the box, when you deploy an ASP.NET MVC runtime, you get what is known as default controller factory. The default controller factory has one specific default convention, and that is to go ahead and then create, that is to go and then look for a controller which has a parameter-less constructor, meaning in none of your constructors, in none of your controllers, you typically go and write a constructor, right? That's because by default in C# every class has a default constructor which is parameterless. Whether you provide it explicitly or not, it is there. You don't know it, but it is there. So the convention is that the default controller factory will automatically instantiate your controller as long as you have a parameterless constructor. So that's what typically happens in a most of the time. So controller gets created, the default controller factory creates that particular controller and then goes ahead and then everything is happy. So the controller factory is actually having an interface called as iController factory. So if I had to take the controller creation into my hands, I should be creating a class, name it as Lohit controller factory or whatever it is, but inherit this particular contract known as iController factory. So that will pretty much, we will see how you can do all this stuff. Let's get to the meat of the action now. So what I've done in the interest of the time is I've already created a small MVC app. So let me run this MVC app and then tell you what this does. I'm going to be tracking the amount of water that I intake in a day. I work from home, so I'm sitting, so my wife keeps saying, get up, work, drink water, all those things. So what I wanted to do was I want to basically track my water intake. So it's a simple thing that I want to do. Of course, in the interest of the time, don't go into specifics, but the goal here is I am tracking my water intake. So at this hour, I took 1 liter of water. So I just go and then say track. So you see the total is 1 hour. So now after an hour, I come back and then I update saying like, hey, I again went ahead and then took 1 more liter of water. So I'm going to go and then say, so now you see that, I've already tracked my 2 liters of water that I've drank today. So now I'm going to go Okay, somebody is saying no need to hurry, so thank you. So it was just in the interest of the time. So basically, this is a very simple MVC page. As you can see here, I have a controller which says water intake tracking controller, and then I have a action method which I call it as track intake. So and then at maybe at 3 o'clock I finished another 2 liters of water. So if I say this, okay, there is totally 4 liters of water that I had taken intake today. So basically the screen is just this much. But from a code perspective, I'm going to now show you what are the things that I'm doing. First of all, I'm a big proponent of modeling everything. So I just modeled this particular intake that I want to do as a intake data. So I have a total, and then I have a goal that I need to match in case of a particular day. Then what I did was I went ahead and created a repository. So I'm a big proponent of repository. I know there is a lot of debate going on. Repositories are good, bad, whatever it is. But I like this way of doing things. I have an entity and I have a repository which works on that entity. So I like that way of doing things. So what I've done is, don't go into the specifics of that. Basically, as the repository says, it's going to act upon my intake data. So it has the get data and then set total and then set goal. Simple stuff. So basically, I'm modeling a repository here. Then, I may want to do some amount of some business logics here. Of course, as of now, it's very simple, but I may want to do some business logic in future. So in order to allow for that expansion, what I've done is I've created something called as intake tracking service. The intake tracking service is actually depending on my repository, because so the tracking service will have total and goal. And in order to track, basically I would need to go use the repository to set the data or get the data, and then I have only one method which says track intake, and then all I do is keep on adding that particular liters of water that I drink. So now that's the service. Now coming back to my controller, very simple controller, but again, I need my tracking service to work with. So because if you see here, I've defined a hardwired dependency on tracking service. I'm setting my view bags with the total and the goal, so that when the page comes up, I will be able to output this. So now, what is the problem now? So far, whatever Abhishek had told us, we have violated everything, right? Meaning we never abstracted anything out, rather we have put everything inside. So now the problem is, in ASP.NET MVC, you can go ahead and write tests against your controller. I can write a test for this controller itself. So now, if I go ahead and write a controller test, although I will be, testing my index methods or any other methods, but now the problem is I will be carrying the baggage of this hard-coded reference. As soon as you put is equal to new and then you new up something, you are in a trap of direct dependency. So this is a direct dependency. I cannot do anything if there's something like this. When I create a new instance of controller in my test, I am actually creating the concrete instantiation of my class, of this service class. So that is a bad thing. Let's say I want to go and then create a I want to do a testing of my service itself, right? So again, in the service, when I go and then instantiate my service in my test layer, again I have a hard-coded reference of my repository. So this is bad because I'm going to get the complete baggage. So what are we going to do? So I'm going to first showcase. Somebody was asking in the question panel that can I do dependency injection without a container? Yes, you can do that without a container, but I'll show you how painful it is. So I'm going to be doing the dependency injection now in a poor man's way. That is, I don't have a container, but rather I'm going to do all the hard wiring now. So first thing that I'm going to do is open up my intake repository. I'll use our just code to refactor this, and then I'm going to extract basically a interface for my repository, and then I'm going to say select all public, don't create a new file, just finish it. So here you can say I extracted out my whatever the intake repository was doing it. I just extracted it and then made it as a kind of a interface, and then that interface looks like this. So this is first step. Second step is as we know, the tracking service is dependent on my intake repository? Well, I can just go ahead and then say like, now you depend on the interface, but still this doesn't serve the purpose. Why? Because although I said it's depending on an interface, but I still have my hard-coded reference. So how do we deal with this? Simple. Elevate the property to a class level, the private variable, and then I will now come back here and then say like, hey, intake tracking service, you will be actually depending on a repository. So I'm now setting up my expectation right up front, saying like, hey, I need this repository which implements this intake repository. Without that, I cannot work. So I set my dependency up front. So this is fine. The tracking service has been set up. Now, what is the other problem? The other problem is the controller. If you see here, now the controller starts to say like, hey, you know what? It needs a intake tracking service, needs the repository. So why don't you give me that? Well, I can go ahead and then do this. What is it? Intake repository repo is equal to new intake intake repository, but this doesn't again solve the purpose. Now we doubled the problem. The problem is we are now having two concrete dependencies right within our controller. So let's not do this. Rather, what we will do is let the the controller still depend on the service itself. So I'm going to create a private variable here, and then I'm going to come back here and then say like, hey, I want a controller constructor. In the constructor, now I'm going to say this depends on intake tracking service, So basically I will say this depends on a service, and underscore service is nothing but the service. Okay, so are we done? Are we cool? Yeah, we went ahead and then removed everywhere the hard-coded sorry about that. So this is intake. So we removed all the hard-coded reference, right? So what's the harm now? So let's try to run it. So now all I'm going to do is just go ahead and then run this particular page. So the home page comes up. Just give me a second for this to come up. So the home page comes up. We never did anything on the home page, but all the work was done on water intake tracking controller. Now, as soon as I click on this, boom, we have an yellow screen of death. So, okay, so what is happening is, if you notice the chain of commands that is happening within the ASP.NET MVC, basically as soon as the process came in, when the request came in, the MVC handler comes in and says, it starts to process the request, it does the process request in it, and then, look at this, default controller factory dot create controller. So, the MVC route handler, it figured out that, I'm looking for a controller called water intake tracking controller because that's there in the route. And then it goes and then tells default controller factory that, hey, go ahead, create the controller instance, right? So what the default controller factory tries to do is, it tries to go and then create a parameterless constructor. If you see here, it right out saying like, make sure that the controller has a parameterless public constructor, whereas at present I do not have a parameterless constructor. As soon as you put a constructor, it kind of hides, and then you don't get the parameterless constructor. This takes a precedence in the constructor deduction. It sees that, oh, this is a constructor which needs a parameter, so it cannot find the parameterless constructor, and then it says, hey, I don't know what you are trying to do, but I need a parameterless constructor. Unless otherwise you give me that, I cannot work. So what do we do for this? So one thing that we can do for this is we can write our own, we don't want to get away from this. We need the controller taking an parameter, taking a dependency injection like this. This is known as the constructor injection, and we want to be with this. We don't want to change this. So the way to solve this is we should create our own custom controller. So what I'm already done is, in the interest of the time, is I've created a class. I named it as custom controller factory, and remember I talked about this interface called iController factory. So I have gone ahead and then I have inherited from iController factory. So this has very simple concept. What it says is it has three things that needs to be implemented. One is create controller. So this is where you come in and then you create the custom controller creation logic, and then get controller session behavior, and then release controller. So these are the three things that you should do. So what I've done is, in order to, okay, I need to stop. So basically what we need to do is we need to just come in, and then if you see here, I get the controller that has been asked for, the name, basically. So I'm saying, heck, irrespective of the casing, if I am getting any request for this controller called water intake tracking, okay, I know what needs to be done. And what needs to be done, it basically needs a service. So that's the intake service. Basically, I'm creating everything, I'm handcrafting everything here. So this is the poor man's way of doing a dependency injection. Oh, okay, I know what's happening. So I never gave the interface to my service, although I had done a interface there. Okay, so now if I come back here, so this is if you don't have an IoC container where somebody takes the headache of creating an object, this is what we call as poor man's dependency injection. So I know my water intake tracking controller requires a service, right? So I need to manually create that service. Okay, I will go ahead and create intake tracking service, but intake tracking service requires a repository, okay, then I need to create a repository, put it to the tracking service, then take the service, give it to the controller. Right? If the request was not for water intake tracking controller, but it was for home controller or any of the other tracking controller, so what I am doing is basically I will fall back to the default controller factory, and I will say, boss, you go ahead, do whatever you are trying to do. So all it does is it takes the request contact controller name, and then it has its own default implementation. It will do it. But so now let's run this, and then we will be able to see that it works. It's not that it doesn't work, but I'll tell you what is the main problem here. So you see that we have an if condition going on. So since the first request is for home controller, my if block will never get executed. This is the other block that gets getting executed, the default controller factory. But now as soon as let me put a breakpoint here. And if I now go into water intake tracking controller, you will see that, okay, I did not build it. Oh, I know. I made a mistake, and that mistake is we created the custom controller factory, but we never told it to use that custom controller factory. So what you need to do is you need to come back to global.asax and tell it that controller builder .current .set controller factory, and I need to give my new custom controller factory. So what I'm doing is I'm actually replacing the way I'm basically telling MVC that, hey, apart from the default controller factory, there will be a custom controller factory. So I need you to make sure that you give me the control whenever there is a controller that needs to be created. So now when I run this, it will hit the home controller / index. That's the default action that has been set up. So I came here. So where is my breakpoint? Breakpoint is actually within this one, so that's why it never hit it. So now let me put it on the if block, and now I go and say water intake tracking. There you go, boom. It has come down to my custom controller factory. Why? Because I told it to do so. Remember in the global.asax I said the controller factory is this custom controller factory. So now from now onwards, any request to any controller, it's going to come here. Okay, so now I know that the request is coming for water intake tracking, so I know I need to go and then manually create my dependency injection. So what I do is I go ahead, I create the repository, I create the service, I inject into the controller. So now if I go to the controller and then controller as an index method, or let's say a constructor or in the index, you will see that the service would be automatically filled up now. So there you go, the index method was called. So now if I look at my underscore service, I have my dependency already injected by the because we manually took care of the injection. So this is fine. So now if I go ahead, everything will work fine. I will see that. Okay, let's get out of this. So if you see here, I can track everything. I'm able to see that it is working perfectly fine. So what is the problem? The problem is whatever example that I'm showing you now is just of one controller called water intake tracking controller. We are talking about an enterprise apps which have n number of controllers, and then each controller will have its own dependency, right? You cannot keep on doing this dependency injection through this if block, right? So there are better ways to do that. So one of the better ways to do that is, I will go ahead remove this custom controller for now, because I'm going to be using Ninject. Ninject is one of the popular DI container or IoC container that we have. So I'm going to just leave that. So all you need to do is just go to Package Manager console, and so if you look at here, all I'm going to do is I'm going to go and then get a package called as Ninject.mvc5, because currently I'm using the Visual Studio 2013, and then I'm on ASP.NET MVC5, but this is pretty much you can do with any of the MVC versions. So if you see here, Ninject has different versions. Currently I'm using MVC5, you can use MVC3, you can use MVC4, depends on which MVC framework that you are on, and this Ninject has those NuGet packages. So all I'm going to do now is I'm going to just come in here and then use this and say like, I want you to install ninject.mvc5. That's all I'm going to do. So all it does is it's going to go ahead, and by the way, another 5 minutes and then we are done with the DI with Ninject. So that's as easy as it can get with the Ninject. So now Ninject has been installed. So basically, as you can see here, successfully added Ninject MVC5 3.2.1.0. So what did it do? Did it do anything magic? Yes, the only magic it does is it adds this new file called as ninject_webcommon.cs_app_start. So basically what they have done is they have written basically the start and stop, they hook on to the start method and stop method. So basically in the start method, they go and then register themselves. If you see here, one per request HTTP module and the Ninject HTTP module, these guys are going directly into the pipeline. They are injecting an HTTP module so that as soon as an MVC handler comes in and then routes the it figures out the route, and it figures out like it needs to go and then create a controller. These guys come in and say, okay, we'll take care of it, and then we'll do it. So the concept in Ninject is basically known as a kernel. As you can see in the stop, they shut down the bootstrap. So basically the bootstrap is nothing but their own way of doing things. If you see here, Ninject Web Common Bootstrapper. The important stuff is here in the kernel, where the kernel gets created. So whenever your app starts, the kernel is created. So you can use a standard kernel. I can create my own kernel for my different modules and all those things. So basically, if you see here, what they're doing is they're kind of registering their bootstrapper, and then also they're registering this HTTP application initialization HTTP module. So basically they say like, for HTTP module, I want you to use this particular concrete type or this particular concrete class. And then this is where you will come in and then say register services. So basically this is a method which is provided here itself. All I need to do now is I just have to say kernel dot bind, and I know I have intake repository. So let me get my usings done. So basically what I'm saying is, hey, in any lifetime, if you find any request for somebody asking for this interface called intake repository, I want you to go and then give them this concrete class called intake repository. That's all I have to do. And then similarly, remember we have intake tracking service, and you will say for that I want you to say intake tracking service. That's all it takes in order to put a DI. Now I don't have to change anything anywhere. If you look at my controller, let me put a breakpoint in my controller constructor. I'm going to remove everywhere. So I'll put a breakpoint in my controller constructor, and then also I'll put a breakpoint in tracking service constructor. So if you say here, so basically the dependency chain is controller requires a service requires a repository, but what we have told the Ninject container is, hey, anytime somebody asks for I intake repository, give them intake repository. Anytime somebody asks for I intake tracking service, give them intake tracking service. That's all we have to do. Now let me build it. Nothing else needs to be done because these two start and stop would have taken care of kind of getting into the HTTP module activation. Everything has been done by this. It's fantastically done. So now let me go ahead and then run. At present, the initial request is going to the home controller / index. Of course, home controller does not do anything. So, okay, we didn't do anything. So now remember, I put breakpoints everywhere. So I'm going to say water intake tracking. Boom. There you go. The first instance that I hit is actually a constructor of the tracking service. But what did tracking service need? The tracking service needed repository, and here you go. I have the concrete implementation of the repository that I get, and that is IoC demo.models.intake repository. So now if this is done, next breakpoint would be the controller itself, right? Remember, the controller is what is getting instantiated, but the controller had a dependency on the service. And now if you see this, I have a concrete implementation of the service given to me by the container. So now this is what Abhishek was talking about, letting others take the pain of instantiation, letting somebody else take the headache of creating a object, and then I only tell somebody that, hey, I need this particular service, or I need this dependency. Let me take out all the breakpoints, and you will see that my application still works as expected. I can see I'm tracking. This was something that we wanted to give you a glimpse into what is inversion of control. The containers are the inversion of control basically, and what exactly is a dependency injection, and then how it helps you in your modularizing your stuff. So
So now what we are going to do is convert the application that was so tightly coupled to a slightly loosely coupled application.